Now it's the time for the next presentation. It comes from France, Julian River. We know River Architectural Agency from the PassivHaus competition in 2014. Now we will have Anna Czerwinska to present on behalf of Julian, but we all must know that the studio is specialized in low energy buildings and bio-based materials, and they also have some marquee projects like the first historical monument PassivHaus renovation and the first PassivHaus hospital facility in France, for which we'll hear just now. So, time for the video of Julian and Anne.
Hello, my name is Julian River. I'm a French architect based in Saint-Etienne and Paris. In our office, we have multidisciplinary teams composed of 12 architects, including 8 PassivHaus designers and 3 structural engineers, 3 economists, including 1 PassivHaus consultant. For the last 10 years, I've been working on many subjects related to energy performance, frugality, and ecological materials. In 2012, we retrofit a listed building into a labellisé PassivHaus office. Last year, we also retrofit a 1962 administrative building on the NFIT standard. Well, now we're going to speak about a new building, a 72-bed dialysis center that I designed for Artic 42 with the following engineering teams: Engibat for structure and economy, Iltec for thermal and electrical applications, Heliasol for PassivHaus approach, thermal bridge calculation, and PHPP. Franck Janin from Heliasol will speak about medical process in a few minutes. Anna Czerwinska works as an architect by my side. She will now present the project's context.
In the case of this project, the investor was from the beginning had an intention to build a PassivHaus hospital and had the PassivHaus approach, and he knew the advantages that come from this type of construction. He also visited our office, which are in a PassivHaus building. This made him appreciate even more the internal comfort that we had inside the office, even during strong heat waves periods in the summer. He got convinced even more that the PassivHaus would be a good choice for his building. He knew that we could achieve rich high hygienic standards thanks to the mechanical ventilation, and that we could improve patients' well-being by assuring a good internal comfort and prevent the dialysis rooms from overheating, and that we could offer comfortable and friendly spaces for both patients and the medical staff. Here you can see the floor plan, the ground floor plan, with the main entrance to the building in the central part, just in front of the green patio. Then in the left wing and in the right wing, you can see the dialysis rooms with small skylights and green walls in the center. The total surface of the building is 4,200 square meters. The treated floor area is 2,450 square meters, and the total cost is around 7 million euro. The building hosts 150 patients. It has got 70 beds and 4 dialysis rooms spread over 2 levels. On this slide, you can see how we define the thermal envelope. You can see that the building has got 3 levels. The 2 upper levels are the medical rooms, and the lowest level is the basement. And you can see that most part of the basement is outside the thermal envelope. This is where we placed all the technical rooms or the power generators which emit a lot of heat. And inside the thermal envelope, we put the changing rooms for the staff, the bathrooms, toilets, and vertical communication, just like lifts or staircases. Here you can see a typical floor plan of the dialysis room with 12 cubicles and 2 additional beds on the sides of the room. In the center, you can see the green wall with a skylight that penetrates the building on 2 levels. And on each side of the skylight, you can see the desks. You can see the same thing on the photo in the upper right corner of the slide. As I said before, the building hosts 150 patients. Those patients, they come to the building 2 or 3 times per week, and they go through the dialysis process that takes 4 hours. That means that some of the patients will spend 12 hours in the building. That's why it was very important for us to make the space as comfortable and pleasant as it could get, to privilege the natural sunlight and the greenery. That's why we created the green patio and the green walls. All this was to improve the stay of the patients and also the work of the medical staff.
Before designing this new dialysis center, we made a visit and a study of the previous dialysis center, and we discovered that the dialysis machines are very exothermic, and their average operating power is 400 watts, and there is 1 machine per patient, so this heats a lot. In this machine, we can see that the water is heated up to 37 degrees, and after the dialysis, we have a cleaning process which will heat the water to 80 degrees. So we made a study to have a better estimation of the internal heat gains, which are really huge. And this led to a reduction of the thickness of the thermal insulation in the wall. But we are still a little above the PassivHaus criteria. Next slide. So this is the infrared photo of an old machine. And you can see that externally we are above 40 degrees in the red area, and so inside it's even heater. Even when the machine is stopped, there is still a lot of heat to dissipate, and so we really have a lot of internal gain. Next slide. Here you can see the new generation of machine. They are they have better insulation, and so the external temperature is a little lower, and it's near 28 or 30 degrees, which is a little below the previous one. We have convinced the investor to change all the dialysis machine to be more efficient and have less internal heat gain. Next slide. So for every patient, we have a dialysis machine which heated a lot. 1,200 watts is the maximum, but 400 in average. And so the final energy consumption only for the dialysis process is 85 kilowatt hour per square meter per year. And if we count in primary energy, this is around 220 kilowatt hour per square meter. So this is far above the total limit for PHPP, which is 120. We have an internal temperature which is not 20 degrees like in office building, but it's at least 23, which is needed for the patient's comfort because they are during the dialysis. If they are in dialysis, it means they are not in good shape, and so 23 is really a minimum temperature for their comfort. Next slide.
The internal supply in the dialysis room exceeds 10 watts per square meter. This is 4 times the value of the standard offices in the PHPP. It means that the comfort temperature is easily reached in winter, but we knew that the summer that in summer we must be very careful. To dissipate the heat, we opted for two solutions. The first one is 5 geothermal boreholes connected to the ventilation system. The second one is an air conditioning system only in the dialysis rooms and in case of strong heat waves. On this slide, you can see the 5 geothermal boreholes location. Each one is 190 meters. The value is 50 watts per meter, so we have a total cooling power of 47.5 kilowatts. We often use these types of cooling system without heat pump in our project. The efficiency is more than 70:1. In that case, pumps in action consume less than 600 watts. The disadvantage is a low power in relation to the investment. So it means that the system is suitable for the PassivHaus project with low needs. In order not to put air conditioning in case of heat waves, it would have been necessary to make 5 more boreholes. We did not have enough money for that. We also studied using 10 cubic meters a day of cold water used for the dialysis to cool down the building. But the cost was a problem, and the doctors didn't thought it was a good idea. Of course, all the windows are equipped with sun breakers in order to cut unwanted solar gain. In this type of construction, more than anywhere else, it's difficult to get people to accept the need to use this system to regulate rather than having air conditioning system. In the same way, the insulation of the dialysis loop here, which reaches 80 degrees twice a week for asepsis, has been reinforced to avoid unwanted heating. There was a lot of specific equipment. The generator is located outside the envelope, as Anna said before. There are also 3 computer racks like this one, 2 in the hot part and 1 outside the hot envelope with the computer server, but in an airtight area in the basement, connected by an airtight pipe. This solution dissipates a large part of the heat from the computer server into the foundation. Airtightness combined with earthquake design is a subject that has required a lot of attention. Indeed, the seismic joints of 4 cm require the very careful installation of a suitable expensive gasket in the masonry. The result of the airtightness test of 0.4 shows that the design and execution were correct. As a conclusion, I can say that this building is an atypical PassivHaus project. The medical process makes the design more complex due to networks, medical equipment, vacuum, oxygen, access control. The high standards of PassivHaus and medical comfort require changing the dialysis equipment, setting up cooling devices in the dialysis room. The heating demands of the building is less than 5 kWh per square meters. We can speak of a building without heating. Thanks for attention.
And we also want to thank Atelier Riva for a beautiful project that they just presenting with lots of nice detailing and excellent internal spaces. Then we can probably ask a similar question to Anne and Julian. First of all, congratulations for a beautiful project, really. And it's fascinating architecture. But I now set my attention on certain things that you said, that when they visited your offices in the renovated monumental building, they got convinced in the benefits of the PassivHaus approach. Was that really the case, and what it takes to convince really a manager or an owner of a hospital to go for a PassivHaus approach? This quite complex building, and even to change the equipment. So that's a change of the mindset, actually.
Yes, that's true. It was not so hard to convince the hospital director because we work in a PassivHaus example. We are in our building. It's a listed building, and so when he came to us, it was not so hard to convince the director that PassivHaus building was the solution. Well, it was harder to convince him to change the dialysis system, but the thermal picture was really a good example, and he understood very quickly when we explained the problem. He had a summer comfort problem, and with the thermal picture, we said, your problem is on this picture.
Yep. And Anna, how would you evaluate the importance of, having good, strong connection and arguments in order to convince the investors to start up?
Well, that's not always easy. We have the advantage of working in a PassivHaus building. So we have the advantage, we often do actually invite clients in the building. Like that, we can present it. We can show that we don't have radiators. We can show the heating system. When we invite them in a very cold days or very warm days, they can really experience the temperatures inside. So I think that for us, it's maybe it's easier than for other architects who don't have the privilege of working in that kind of building. But yes, we have different clients, and we, as other architects, we often struggle with investors. We struggle to convince them, especially when they see that it will cost them a little bit more. They are often hesitating, but from time to time we manage.
Thank you, and everybody that are engaged in the investment process, and actually, and this is what I see in the chat box. This session, in my opinion, convinced us even more that we have to work on PassivHaus or EnergFit in order to achieve the quality and the comfort, the satisfaction of the end users of the buildings, that we also, that people are really, really happy to habitate, to live, to work in these projects. So I think that we don't have any more burning questions, and I see that the organizers are already inviting us to the PassivHaus Cafe. If that's all, I think that we can really thank to all 6 presenters, and we can obviously promise that we are all available for continuation of the discussions, first in the PassivHaus Cafe and later on via email, Skype, whatever. So we can definitely benefit from these great relations that we have established under this conference. So thank you very much, all. Thank you very much.
Thank you.
Thank you.
And it was really a pleasure moving to the cafe.